All right, ready for video. Welcome back to the show, everybody. The Farmall H tractor starter and generator diagnosis, repair, and reassembly process continues. So, although this may look like an intimidating pile of parts to some, I assure you everything here is so crazy simple. By the end of this episode, you will gain the knowledge necessary to then not be able to understand why anyone in their right mind would take a tractor in all of its vintage awesomeness such as this just to cobble a bracket so that they can cobble an alternator, to cobble the belt, to cobble the wiring, and on an H because there's not enough room here. That usually results in a hood cobble as well, where we slid it here and turn it into a wing because we're all like, GM1 wire, woo! It's like, we don't do that here. Seriously, not to offend anyone, but I am a staunch proponent of generators with external regulators, especially on equipment that was not originally equipped with an alternator. There is an argument to be made that alternators are more reliable than generators. I disagree. I have the same argument with the individuals that cry the loudest against starting engines, pony motors, donkey engines, whatever you may happen to call them in your corner of the world, on the older Caterpillars, because my experience has been the people that do not like starting engines and promote direct electric start are also the ones that have never operated a starting engine system that didn't have multiple things wrong with it that required correcting. Same scenario with generators and external regulators. Most of the people that dislike them the hardest are the ones that have never had a system that's truly been returned to 100% proper spec. So with a little bit of knowledge and a couple of the right investments from the vintage market swap meets, this will be your bag. Trust me. Now, everything that is on the bench right here that was original to the Farmall H has been gone through off camera, and the reason why I chose to do that is because I did all the major reconditioning to these pieces the last time through, and all I expected to have to do this time was just a light cleaning and refreshing. Sure enough, that's how it played out. So that's why I've got this other generator disassembled on the bench here. It was a core we picked up in rough condition. It definitely spent some time in the ground, but it will be the perfect test bed for the recording of this episode. I did get a couple of questions the last time, though, about best practices for cleaning these electrical components. I do shy away from solvents when I'm working on anything that has windings like these armatures or the coils that are inside the cases. Reason being, there's a lot of laminations, there's like some paper layers, there's a lot of wires that are wound tightly around one another, and solvents can creep in and then stay behind. And if you did clean these with a solvent, I would recommend baking the last of the vapors out under a low heat. Personally, I prefer like a CRC electrical cleaner, something that's made to evaporate cleanly and completely. You might be taking a chance with certain brake cleaners. Just be confident that it's not going to attack any of your finishes. Sorry about that. But that's how I gently clean any of these components that don't require complete disassembly. So to start the process, we'll go back to our test mule here. You can see I've got the armature placed in the soft jaws and the vise. The first thing we are going to do are the basic electrical tests to this to see if it's even worth going any further on. And for all of these steps, all you need is a simple electrical multimeter. So first test that we do, we turn our meter on to the ohm scale, and you can see the readout right there. That is an open circuit. All right, so we zero our leads. We see what our margin of error is, 0.1 of an ohm. All right, so we deduct that from any reading we get that we take from this point forward. And it's very important, do not touch the probe ends with your fingers, because you see, that's the resistance of me right there, all right? There we're back to being an open circuit. So even do not touch the pieces that we are testing with your fingers while you're testing. So if I've got my one lead on the end of the shaft, but my finger's on the shaft, my other lead is going to be on the commutator, but then my other finger's on the commutator. Watch the display. See that? That's the resistance of me you're seeing. That's the resistance of what we're actually checking. See what I'm saying? That's how easy it is to contaminate your reading. So make sure that only your leads are touching what you're testing. So we want to make sure we don't have any shorts of the commutator to the shaft. So make sure you got a good clean purchase up there on the shaft. And we'll just start out and we'll test each commutator segment one at a time. And we're going to want to, in a perfect world, see that out of limits open circuit, okay? And we will just touch each commutator segment all the way around. We want to make sure we have the same open circuit, no continuity there whatsoever. Now, once you've been all the way around, what we want to do then is make sure there are no dead spots in the commutator. So we'll put one lead on one of the segments and we will check it to the leads the rest of the way around. You can see we are 0.3 of an ohm right there, 0.3, 0.2, 0.1 there, boom. We're pretty good continuity, factoring in our margin of error on our leads. And you just want to go around and just make sure you've got very good continuity, as close to no resistance as possible between all of the commutator bars. And just one left. Very good. We've passed the first test, and that means we have about a 75% chance that this armature is going to be good. But on to the next step. Okay, the next step is going to involve the growler. We've got the cord, leave that unplugged for now. This is basically a large electromagnet. You can usually pick these up pretty cheap at the swap meets. Most people walk right past them, don't even know what they are. This one is very old. Wallace Manufacturing Company, Minneapolis, USA. No idea how old, but it's up there. So we've got the V-block portion on the top. That is where a strong magnetic field is going to be induced once this is plugged into the wall. And what you do is you take the armature, and the steel laminated segments are what get placed into the V-block. I usually like to find where they stamp the part number, and that is going to be my indicator for a complete 360 revolution. One thing you definitely want to do is get this placed on the growler first, because when you plug this in, A, you're going to learn why they call it a growler. B, it is going to want to pull this armature down hard onto that V-block. Definitely do not have your fingers in the way. So I'll just show you here real quick. If I just lift it up a little bit, once we plug it in, it pulls it down right away. So don't have your hand right there. We'll plug this in. It's going to make its noise. But what we want to do is test for any kind of magnetism on any of those steel laminates with something thin and metallic like a hacksaw blade, all right? And we'll just go all the way around. If we have a short anywhere in this armature, this will stick like it's magnetized. If the armature is good, fully insulated, it'll act just like when we still have it unplugged. So let's go. So far we're good. And it's held down so tight, it takes two hands even to turn that in there. We just want to work all the way around, hit every one of those steel segments. So far, so good. Yep, nothing yet. And we're back around to our numbers. All right, good. We growler tested good, so that means we can move on to dressing up the commutator. Enter the tri-cut armature lathe and undercutter. Now, this is not a necessity piece of equipment. It is, however, a convenience item when it comes to working on starters and generators. It's just a purpose-built machine that lives to just rehabilitate commutators on armatures. Okay, carries out two functions, and that's pretty much it. So you can get by without one of these as long as you have, say, a regular lathe like that, and just a good old hacksaw like the one that we used with the growler. Once I show you all how this works, you'll know exactly what I'm talking about. But pretty simple setup right here. An adjustable tail stock, all right. It has two chucks on it, one on this end, one on the other end here. and they have this rotating collar on the outside, and that centers these 3 bronze pucks down onto the shaft ends of the armature. All right, so that's how you fix that in position. And we have, this is a cutter bit, just like on a regular lathe. It has adjustments for in and out. You can lock it in position, and then you just crank it on down the way, and that will true the commutator bars right here. Once you get those trued out, then you undercut them. That's what this attachment is for. It's got a tiny little saw wheel on it, and you run a little round belt to power that. We have the vertical adjustment lock right here, vertical crank up and down, and you feed that with this lever on the front. You can see how that will go and cut the mica out from between the commutator bars, okay? And for repetitive jobs, say you had 10 of these just like this to do in a row, we have these adjustable end stop pucks behind each chuck, held in position with a thumb screw, and that would allow you to set the lathe up to the first armature, and then after that you can just easily slide the tailstock back, change the armature out, tailstock back forward, over and over and over again. So pretty simple setup and how it works. Let's put it to use. Always to keep plenty of oil in those chucks, because that's all just friction in there. So now that we've got that set, the way this drives, the motor has this pulley on the end of it, and we've got these flat belts, and they just go around the steel portion of the armature. And belt tension is set by this, it's basically a kickstand. There's another thumb screw in the bottom, and that rod will go up and down, pitches the motor, which tensions the belts. So we're good to go here. I can tell by looking at this, so we've got a pretty good step right here. So we're high out here on the end. You can see where the brushes wore in, so that's all low, all the way through the mid-range there. But toward the inside, there's an even larger step that is more pronounced, and I can tell that I'm going to have to run the cutter bit in far enough to take this one down first before we can reset and start doing full passes. You can really start to see how uneven the face of this was from the wear. Now we're just starting to contact a little bit. Hopefully final pass now. If I can get rid of that dark line, we'll be good to carry it on through. Yep. Very good. Okay, now that we are trued up, we can use the little undercutter sawtooth wheel to remove some of the mica insulation from between the commutator bars. You can see I've retooled with our flexible round belt through all the pulleys. That is what is going to drive that wheel. And the reason you want to undercut the commutator on a generator is to save on the brushes. All right, these brushes are fairly soft, and as they wear in to the copper, if we did not take that mica out, it would turn into a very fine grinding grit, and it would wear the brushes right out. So you always want to undercut the armature on a generator. However, a starter of this vintage, you typically do not want to undercut it because, well, we have a lot different grade of copper, starter to generator. The starter brushes are a lot more resilient than the generator brushes are. And because a starter operates in a higher amperage environment, if we were to undercut that mica from between the bars, we could actually drag some of the copper from one bar to another. That starts causing shorts, starts defeating the purpose of the windings in the armature. So you just want to true the starters and then leave them be after that. And this is also where the old hacksaw blade substitute comes into play. I mentioned it earlier. If you do not have a fancy undercutting wheel like this, once you true the commutator, you can just take a hacksaw blade, carefully saw some of that mica out from between the bars, and you're good to go. Nothing wrong with that method at all. It's been used for decades. The only real benefit to an actual fixed position wheel like this, it just gives you better, more uniform results. Now this is a very manual process. You just align the mica with the cutting wheel, hold the armature from turning by hand, and just advance your cutting wheel on down. You can see the white dust coming out. That's what we've removed. And you just want to stop short of the very edge, just like that. Turn it around to the next one, realign, again and again. Work your way all the way around. So now we can remove this from the lathe, and just like that, we have a fully tested, verified, and reconditioned spare armature for an IH generator. We were able to pull that from our rough core over there, and nothing we've done here yet has been difficult at all, and it hasn't even required the use of this specialized piece of equipment. With all the other workarounds you've got and just a digital multimeter, you can pretty much do everything we did here with almost the same degree of certainty. So all those same steps have been performed on the two armatures for the H's generator and starter. And we're at the point with these right now, we can start throwing like the nose cone, the starter drive, this front bearing plate pulley. We can start loading pieces on both of these armatures. I think we are going to hold off for now. We'll do that next episode. But another brief word about the old tri-cut armature lathe and undercutter. This is the standard size of these units. I want to show you something though. Senior has been actively restoring the long bed deluxe version of the tri-cut. All right, this is for like the big Delco 42 MTs. I mean, huge units. It has a tailstock that'll slide up and do all the standard length stuff that this one will do, but this one affords you much more flexibility, and it's also kind of the deluxe version. This one not only has a motor that drives the armature, it has a separate motor just for the undercutting wheel. Here's the bracket for that. It'll mount up back here. Otherwise, it's got the same handle for guiding that back and forth. You can see he's working through some of the rest of the feeds and the chucks and everything. We've had this on the members channel a couple of times. Senior prefers hanging out over there with the relaxed atmosphere that comes with it. But so the plan is he's going to finish restoring this one. You can see he's got the wood base over here already done for it. So we'll have this long bed deluxe, we'll have this standard version, and we've got two more of these that we have collected over the years, and he is also actively rebuilding those at the moment. We are planning on getting rid of those two units because we don't need to have we don't need to have four of them when two would handle everything that we would ever have to do. So if you are in the market for one of these armature lathes, good chance we might have a couple of them at the LeSueur, Minnesota Pioneer Power Association swap meet coming up here at the end of April. So be on the lookout for that. Thank you for watching, everyone. I hope you found it entertaining. I hope you found it informative. and I hope to see y'all back next time.